Hello friend, welcome to our channel Luminous Physics. Today we will discuss superconductivity. Basically in this lecture I will discuss only the formulas, no derivation, only important formula of superconductivity. So let's get started. Superconductivity. First we discuss the flux quantization. Flux quantization. We know flux quantization phi equal to, we write in phi 0, which is equal to nh by 2e for SI unit, nhc by 2e for CGS unit, where H is Planck constant and I0 is smallest quanta of magnetic flux. Basically it's called fluxion. Now we'll discuss about the important formula Meissner effect. Meissner effect. The important thing is the condition of the Meissner effect, in which condition superconductor show the Meissner effect. This is the very important thing. At T less than Tc and H less than Hc, superconductor show Meissner effect, where HTC and HC are critical temperature and critical magnetic field. Basically in this given condition at T less than Tc and H less than Hc, we jump normal conductor to superconductor state. Properties of superconductor. Number one properties are in the application of the external magnetic field, which is less than the critical field, and also the temperature which is less than the critical temperature, we will see that the normal conductor behave as a superconductor. In this stage, the magnetization will appear as a negative of the magnetic field lines, and also our magnetic susceptibility will be negative. So basically superconductor behaves as diamagnetic. Diamagnet. And also we know mu bar equal to 1 plus chi. Which is equal to 0. And also B inside B in means inside the superconductor magnetic field is equal to, we know basic formula, mu 0 h plus m, which is equal to also 0. These are the important properties of the superconductor. And the picture which is to be remembered, this is the picture has to be remembered. At condition T less than Tc, H less than Hc. We know that superconductor are two types. Types 1 and type 2. In type 1 superconductor, we have to remember that the coherence length always greater than the penetration depth. Number 1. And in type 2 superconductor, the coherence length less than the penetration depth. These were the important information which has to be remembered. And second is the graph between minus m versus h. For type 1 superconductor, the versus minus m versus h graphs look like this. This will be minus m and this will be h, and this will like this part is superconductor and this part is normal conductor. Now similarly for type 2 superconductor, we draw the graph minus m versus h. This will look like this one. This minus m and h, and the graph look like, firstly graph up to HC1, then decrease at the magnetic field is C2. This region will be superconductor. This region will be mixed with superconductor and normal conductor, and after HC2 type 2 superconductor behave as normal conductor. So these two curves are important for type 1 and type 2 superconductor, and also two important formulas for the type 2 superconductor, which is HC1 equals to 50, which is the flux on, by pi lambda square, and HC2 equals to 50 by pi ln0 square. So remember it. The most important thing I have forgotten, which is remember the band gap of the superconductor is always 1 MeV. MeV not mega electron volt, it's milli electron volt. Hc at temperature T equal to Hc at temperature 0 into 1 minus T by Tc the square. And number next is the energy gap at Kelvin temperature equal to E G at 0 Kelvin to 1 minus T by Tc whole to the power of. Next, lambda C means penetration depth at temperature T equal to penetration depth at 0 Kelvin to 1 minus T by Tc to the power 4 whole to the power minus of. Actually lambda Ct will be the critical penetration depth at temperature T, and lambda C0 is the critical penetration depth at temperature 0. Next will be number of superconducting electron at temperature T equal to number of superconducting electron at T equal to 0 into 1 minus T by Tc to the power 4. So this four equation also very important. Now next we'll discuss the isotope effect. Isotope effect basically here we remember only one formula, which is the critical temperature Tc is proportional to 1 by root m. Also theta c proportional to 1 by root m. Also we write Tc by theta c to constant, where Tc critical temperature, and theta c will be dy temperature. So if we consider a wire of superconductor, then the current through the superconductor will be called critical current, and which will be calculated through this formula IC equals to 2 pi r HC. It's look like ampere law. We know from ampere law V dot dn equal to mu 0 I and equal to mu 0 is dn equal to mu 0 I, and H equal H into dn integration of dl to phi r to I. So I equal to 2 pi r h. So remember this. The current density equal to IC by area, which means 2 pi r by HC by area of the wire pi r square, means 2 HC by r. Remember the unit of AC is ampere per meter, and remember unit of VC will be Tesla, and then calculate it according to the question. Next, I will discuss the two London equations of the superconductor. So first one is dj by dt equal to n superconducting n square E by m, and number 2 curl of j is equal to n square v by m. These two are the most important formula. You should also remember the formula of penetration depth, which is m by n mu 0 square. Next, we discuss about the Josephson effect. Josephson effect basically the tunneling effect between two superconducting states. First effect called DC effect. When the two superconductors attached by a thin insulating layer, then the electron-electron pair will be tunneling through this thin barrier from one superconductor to another superconductor. So in this case, Josephson current will be like this: I equal to I0 sine delta 0 plus Q by H cut integration dt dt, where V is the voltage, which is the function of time. Now put V of t equal to 0, then we get I equal to I0 sine del 0. So if we put nothing voltage, we get DC current. Next is AC effect. Here we put a constant voltage Vt equal to V0. Then we see we get a AC current del 0 plus Q Vt by H cut, which is called AC effect. We write it sin t plus del 0. So omega equal to Q V0 by H cut. Also remember this, the charge Q equal to always 2E, because this is the charge for copper pair, and copper pair basically formed by the 2 electrons. So Q is 2E, and we also write omega equal to 2E V0 by H cut. So this is for today. Thank you.